Good morning, everybody. Today we are going to do video number 3. This is Algebra 2. It's Monday, April 6th, and our objective is going to be to learn to use the trig identities to simplify trig expressions. Under the Algebra 2 information, there's a page called Basic Trigonometric Identities. You will need this for the assignment. Just keep this beside you while you're doing the problems. We'll start off slow, meaning that I'm not going to give you a lot of these to practice. I'm going to give you 7 on the new Alex quiz, and they're due next Monday. So I am going to give you some examples of how these work. Basically, we use trig identities to simplify trig expressions. So we'll start off with the sine of theta times the secant of theta. Sine cannot be simplified. It is what it is. Secant, though, we know can be changed to cosine. So we change secant to 1 over cosine theta and rewrite as sine of theta times 1 over cosine theta. Since these are being multiplied, we can multiply straight across and rewrite this is sine of theta times 1, which is sine theta, and then it's over cosine theta. Sine over cosine is one of our basic trig identities. It's on your sheet. Sine over cosine is tangent. We can rewrite sine over cosine as tangent theta if you can get to the point where you're either down to one trig function or there's no fractions left. It's finished. These will take you a little practice to get used to, but this is the basic idea, to rewrite something that's more complicated to something that's less complicated. I'll show you another example. So for the second example, we are going to start off with cosine of theta divided by secant of theta. One common strategy with these types of problems is to change things into all sines and cosines. That's not always the best strategy, but oftentimes it is the best thing to do. So for instance, the secant can be written as 1 over cosine. So I rewrite this problem with cosine of theta, that's the same thing here, and then secant of theta I'm going to change to 1 over cosine of theta. Again, that is on your sheet. I'm going to change this 1 over cosine of theta to multiply by the reciprocal because we're dividing. So I'm going to rewrite this as cosine of theta times cosine of theta over 1. I change this from divide to multiply by the reciprocal. Cosine theta times cosine theta is cosine squared theta. And you can put the 1 underneath it, but this is done. We started off with a fraction, we used our trig identities, and we ended up with a single trig function. That's generally what you're going to try to do. Here's a third example. I have 4 for you all together today. My advice is to watch all 4 of them, but again, you control these videos, so you'll do what you feel is appropriate for you. The third example is a little different because it has an addition in it, and I'll show you how you generally handle problems with addition. So we're going to start off with tangent of theta plus the cotangent of theta. If you're adding or subtracting with these problems, almost always you're going to attempt to get common denominators. But first, let's change these to sines and cosines. Tangent is sine over cosine, so I'm going to rewrite tangent as sine of theta over cosine of theta. Cotangent is cosine over sine, so I'm going to rewrite cotangent as cosine of theta over sine of theta. Two fractions, I can get a common denominator. The common denominator between cosine and sine would be cosine sine. Just by multiplying these two together. Now, I need to make these both be cosine sines. This has a cosine already, so I give the top and bottom a sine. So I'm going to give this a sine and this a sine. The top part becomes sine squared because there's a sine theta times a sine theta. To make this one into a cosine sine, it already has the sine, it needs the cosine. So I give it a cosine to the top and the bottom. So now the top has a cosine theta and a cosine theta. So it's cosine squared theta. So instead of, remember how I do this, instead of writing two fractions with two like denominators, I write one fraction with one of the common denominators, the sine squared plus the cosine squared. Now, this is a basic identity. It's on your sheet. It's called the Pythagorean identity. Sine squared plus cosine squared, if you look on your paper, is the same as 1. And then you have your common denominator, which is cosine theta over sine theta. So this sine squared plus cosine squared didn't magically disappear. If you look on your identity sheet, you'll see that sine squared plus cosine squared equals 1. That's how you use trig identities. Since this is the same as 1, I took this whole entire piece and I made it just into a 1. That's what identities are for. So now, I don't like it left as a fraction. So I'm going to change these. 1 over cosine is secant. So I'm going to rewrite this as secant theta. The 1 over cosine turned to the secant. The 1 over sine, I'm going to change to cosecant. And the problem is finished. I have no addition anymore. I ended up with secant theta, cosecant theta, and no fractions. So this problem is finished. This will take you a little practice. And for this week, we're going to concentrate only on using these identities. One last example, and again, I would watch all 4 of them this time. So the last example, it looks more complicated than the first 3, but you're going to see that it simplifies pretty easily. So I have 1 minus sine squared theta all over sine theta plus 1. So 1 minus sine squared theta looks like one of the Pythagorean identities on your paper. And you could actually match it with one of them. But remember that we know how to factor, and you're going to use factoring for a lot of these problems. 1 minus sine squared of theta is a difference of squares. So I can factor the top of this. And it just takes practice before you know what step to start with. 1 minus sine squared theta is a difference of squares, so I put a 1 and a 1. And for sine squared theta, I put a sine and a sine. Just like we were factoring a regular algebra problem. And remember, when there are differences of squares, the only thing you need to do is put an opposite sign in each one. So 1 minus sine squared theta changes to 1 plus sine times 1 minus sine. That allows us to cancel. Remember, you cannot cancel parts of things being added or subtracted, but entire factors. 1 plus sine theta and sine theta plus 1 is the same thing. Those are gone. We're left with 1 minus sine theta. No fractions. Started off with a complicated fraction, we factored it, canceled, and look what we ended up with, something that's much simpler. Sometimes it's hard to know when you're done with these problems, but in general, once you've taken this and made it into an easier problem, you're finished. Today's Alex quiz only has 7 questions, and it's just practicing these. Remember to have your trig identities next to you when you do these problems. You can get help from me either by sending me a screenshot on Remind, and I'm going to have my regularly scheduled Zoom office hours tutorial tomorrow and Wednesday, and you can go to any of the classes that are Algebra 2. Thank you very much.